So the web's wearing out, and I want to show you a couple pictures to illustrate what I mean by that. Here's a picture of what a web application looks like, your classic three-tier architecture. And the two things I want you to see here are we have a database and a CPU, the app server, that are physically close to each other. So they can be fairly chatty back and forth. Think about like a Rails app or a PHP app. And then we've got a protocol that sends the output of that application to the user who's relatively far away. So that's the high latency connection between the app server and your mobile phone or your laptop. And the protocol we use, of course, is HTTP. And HTTP was built to serve documents, right? It was a document hypertext transfer protocol. So it's very good at that. And the rule here is that the web server in this classic architecture generates a page and sends that down to the user who looks at the page. Every time the user wants to do something new, the server essentially starts from scratch and builds a new page. We've all heard this story, right? It's not what we're building today, right? This is what we're building today. It looks a lot more like the app server has somehow moved to where the person is. So we've got an application running in JavaScript in a browser, or we've got an app written in Objective-C running on your iPhone. The high latency connection is now between the database and the application. And we actually don't have a very good story for what that protocol looks like. Today we do it over HTTP or some strange use of HTTP, but we're using it very differently, right? This is now a bidirectional conversation. It's structured data. It's not HTML documents. The application isn't asking for finished pages from the database. It's actually getting little pieces of data here and there. So what I want to talk about and show you is why building an application like this is fundamentally different. It's not an evolution from, say PHP to Ruby to JavaScript, or from one variant of Ajax to another. It's actually a fundamental shift in how we're going to build and structure applications. And the reason I'm so confident in that is that we can look to the past and see something very similar before the web grew up. So if we go back before the web and we draw a picture for what the client-server era looked like, when you had Windows desktops and you had enterprise data servers, and you had these protocols that the Windows computers spoke, NFS and IPX and all these things, it looks exactly the same as what we're building today, right? You've got software running right next to the person, because that's what lets us build these really rich interactive interfaces, and your data is far enough away that you need to design a protocol and a transport that effectively manages that back and forth flow of data. And in fact, I can go one step further back to the 70s if you want, and talk about, call it the mainframe era, which actually looks a lot like the web. Way back then, we had the CPUs and the databases right next to each other, and the CPU generated a finished page. Now, back then, it was like a VT220 page or 3270 or something, right? But very similar model to the web. We would display a page, the user would type a key, the server would update the screen. So it looks like what happens over time is that the place the application runs oscillates back and forth. We've had eras when it was on the server, in the data center, and then we've had eras, and I think we're entering an era when the application is actually closer to the person. And I think if we look back to what the client-server era looked like, we're going to find a lot of motivation for what a new generation of technology built around these rich client applications is going to look like. That's what Meteor is designed to do. It's a departure from the legacy web stacks and an expression of what a great software development environment would look like if you just wanted to build for this sort of modern application platform. So I could go on for a while, but I really want to focus on one piece of what's different, and that's the protocol or the conversation or the flow of data. And the reason I wanted to talk about that today is because it ties in with the security work that we've been doing for the last 6 months at Meteor. So HTTP, I mentioned, is this current protocol that we still use for the most part to communicate between these rich clients written in JavaScript and the server. It's the wrong protocol. It's just absolutely wrong. HTTP is stateless. That's wrong, right? HTTP is essentially unidirectional. That's wrong. HTTP is unreliable. That's wrong. If you look at how we designed all of the RPC protocols in the 90s, we got this stuff right. But when you try to implement client applications over HTTP, you end up running into all of these flaws. And we can talk about WebSockets and we can talk about these low-level transports, but what's missing in that picture is what's the higher level protocol? What's the equivalent of HTTP for bidirectional JSON data? And I think the answer is it's sort of everything that HTTP isn't. It's session-based. It's something that has an understanding of a connection and a replay cache so that when a client asks the server to take an action, we can do that action once and only once. It's something that has the ability to marshal things like JSON data or other structured objects without going through all of the overhead of HTTP and the headers for each document and so forth. So what we've done with Meteor is arranged our data transfer exactly that way. And rather than the REST model, which is designed around, well, you have these HTTP verbs, I guess we'll send some JSON that way, let's think about it from scratch. And the first thing you discover is that in this new world, you don't want snapshots of data. You want an ever-changing flow of information being sent down to the client. And one way to think about this problem is that when your whole app is written in JavaScript or in Cocoa Touch, you're not going to refresh the page. So the server needs some way to push updates, and we all know this, right, because we're building apps this way. But we're doing it ad hoc, and the right way to do it is to bake it into the actual wire protocol that the client speaks. So if you think about what it looks like to have a subscription, then you need a place to put that data, and so you end up building a cache on your client to hold all of this data that the server's been pushing down. And again, people are building this in an ad hoc way. So Backbone Collections, for example, is sort of like your poor man's cache on an HTML5 app. So we'll take a page from the 90s. If we want to change data, it's pretty clear the client's going to have to ask the server to do that. Let's just call it an RPC, because that's what it is. And we have one cute trick we can play that I'm going to show you in code. I won't talk about it too much, but the point is we can work around the latency of the connection by simulating what the server's about to do without waiting for it. And that's what makes applications written in this style magical, because you can take actions on the screen that are very fluid and responsive without waiting for that lengthy round trip, maybe over an unreliable cell phone network or whatever you're using for the response. So here's an example of what that subscription might look like. I put a couple of bits of code on the screen. Let's say you're writing a blog engine in this new style. And I've written 3 JavaScript functions. These would run on the server, and they would define an endpoint, a subscription, for data. You can think of it the same as like a GET and a REST endpoint, except that these are always sending the results of the query. So as posts get written, and these are in Mongo syntax, or if the author I'm looking at writes a new post, then the server is going to push an update down to each client corresponding to the query that's up on the screen. Yeah? So the question is, if we're going to replace HTTP, what do we do about the fact that HTTP is really friendly to networks and proxy servers and firewalls and most other stuff isn't? I mean, you're absolutely right. So I think the future is clearly WebSockets. I think there's a panel this afternoon about the future of WebSockets. I think the future is strong. But in the interim, we'll use hacks. So we'll run all of the ways to simulate a WebSocket over HTTP. Meteor actually doesn't use WebSockets. We have found in production that they don't work very well. One example, just to digress completely, you can't compress traffic over a WebSocket, right? I mean, you could do it in JavaScript, but the native transport doesn't handle compression the way that HTTP does. So if you're sending a lot of JSON back and forth, we actually find it's more efficient to pay the overhead of doing long polling or some other HTTP technique because your actual payloads get much smaller over the wire. So it'll be a transition, right? But I mean, web browsers are going to get the ability to open sockets, and it's going to connect. I mean, that's going to happen, I think, pretty clearly. So I'm more interested in what happens above that transport layer. Let's assume you have a reliable stream, and the question is, what do you send over it? Does that answer your question? So on the client, we just tell the server we're interested in one of those streams. So here's an example of subscribing to the 3 endpoints I defined. And this is kind of interesting because it suggests that a client can subscribe to overlapping sets of data, right? I might be interested in being up to date with, well, all public posts, all posts that a particular author wrote, and all posts that I wrote. And if you looked at the previous screen carefully, you'll see that my posts, they don't have to be public the way the other two do. So you can imagine that there are documents that are matched by more than one of those subscriptions. That's fine. This is the way a modern client assembles the data that it needs. And the goal here is that once I've got that data in my cache, I don't have to wait for the network anymore. So I have a fast local copy of all the data I'm interested in. The server in the background is keeping it up to date. But when I do a query, and this again is Meteor code, and I'll do it on the screen for you, when I do a find, I don't get back a callback or some kind of promise or anything like that. I get back an array of data immediately, right? Without any blocking for the network, without any round-trip latency to the server. And again, that's how you make a responsive application. So the application's job is to tell the server what it's going to be interested in so that it can always be responsive with what it's putting on the screen. And then when we do an update, we want to be able to make the update using the same database API and the same syntax we're comfortable with. So in Meteor, when you have a client, you can do, for example, an insert. And again, I'm going to show you this. The cute trick here is we can do it right away on the client and then figure out whether or not the server decided that was OK. And I'll show you how that works. But again, it makes for a more responsive experience because you can avoid waiting for the server's response, which we call latency compensation. All right, let me show you just a couple things here. So I've defined a collection called circles in my program. And this program is very short. It's only 60 lines of code just to draw the D3 circles. So the really key line is this definition of a circles collection. And by default in Meteor, when you define a collection, to your point earlier, we're going to cache everything in the collection onto every client. So this is, think of it like scaffolding in Rails. It's just a way to get started very quickly. So that means in my browser, and I'll use the console to show you this. Sorry, let me just. Oh, where'd my window go? I can run database commands. So for example, I can insert a circle document, and I'm using Mongo, so I'm just going to give it a JSON document. And in my little setup here, I just need an X and a Y coordinate. So I'll say 200 and 200, and I think it was like a radius of like 20. Hopefully I'm doing this right. And a color of 0. And when I run that insert, D3 maps that XY color choice to a circle on the canvas. I actually have an event handler, so I can also double-click on the canvas, and the client code will run the exact same insert. It's going to pick, I think, a random radius. So here's one, and here's one. And I double-click twice. I can also do circles.find.fetch, for example. And there's my local database query that returned an array of objects. So each of these objects is one of the circles that's on my screen. And if I look at one of these, I see I've got a primary key. This looks like a Mongo ID kind of thing. And then I've got my different properties of that object. What's really cool is that I have the whole Mongo database here in the client. So for example, I can do circles.update, and let's use the Mongo syntax for update every circle, and maybe I'll increment the Y coordinate by 50 pixels, and I'll say multi-true so that it affects every matching document. And D3 moves all 3 of my circles down the screen 50 pixels. That's kind of cool. But we can do a lot better, because it turns out all of this is persistent. And in a totally different browser connected to my server, I can get the effect of having these nice subscriptions. So let me increment y by -50, and you see that both browsers are going to dutifully move their red circles up on the screen at the same time. So this is a transaction in one browser that's going back to the Meteor server, but because both clients are subscribed to the set of circles, when there's a change in any of these documents, that change is reflected on all the other screens, and then D3 takes over and does that nice animation to actually show us what's happening. I have another event handler where if I click a circle, it'll rotate through some colors, and again, if I click on a circle in Safari, the same result in Chrome, and I can play this game all day. But it's a really nice demonstration of sharing data back and forth. So the question this raises is, what stops some guy from opening the console and, circles.remove, and, there's the end of the party. So up until now, my answer has been sort of wishy-washy and complicated. But what we can now show you is something a lot more pleasant about how security works in an environment like this. So I'm going to just sort of zip through a tour of what's now possible with the kind of technology that we have in the upcoming release. So the first thing I'm going to do, and again, please interrupt with questions. It's really a lab course. The first thing I'm going to do is put a circle back on the screen. So let me get a couple of circles here. If I go back to my terminal, let's remove the insecure package, because that seems like the first problem. And I'm going to run the same circles remove command, and I get an access denied error. And if I have that other screen up, I'm sorry there's so little real estate here. Obviously my command did nothing. Now it did nothing everywhere. So the server is now rejecting my request because in secure mode, it now enforces some sort of permission checking on these updates. And I have to write a function that explains what I'm allowed to do. So I can write that function. And what I can do is I'll just add a little stanza of JavaScript where I say circles, which is my collection, .allow. And allow takes a dictionary. So there's different operations we're interested. We've got insert and update and remove. Let's make we'll just do the remove action. So remove is a function, and it's going to take a user ID, and it's going to take, I think, a set of documents that are proposed to be removed. And I can just return true. And if I remember this syntax, I've now defined a rule that says clients are allowed to issue a remove command. So I'm sort of back in the Wild West, where if I come over here and I do a remove, all my data goes away again. So I'm now under this sort of manual control of what each client is allowed to do. Let me add one more piece of manual control. So I'm also going to remove the auto-publish package. And auto-publish is the other half of scaffolding. It's the piece that automatically keeps all the clients up to date with all the data on the server, which is great when you're playing around and not so great if you're building something at internet scale. So now I have to go back to what I was showing you before about subscriptions and having the server publish sets of documents. So let me write what that looks like. So again, on the server, I'm going to define a publish, and I'll just call it all circles. Publish is a function that's going to return, in my case, a database query. So on the server, I'll do circles.find and balance all. Oh, no. And so now I've defined a document set, right? An endpoint that a client can connect to retrieve some data. And it has a name which is all circles. And then on the client, I'm just going to subscribe to that. So I do meteor.subscribe, all circles. And if I save that, that should put me back where I was. I actually don't think I have any circles in the database, so let's, oh. So if I double click, here's an interesting example of that latency compensation. So watch the screen. I double click, and my double click handler inserts a circle object. So it puts it on the screen. D3 dutifully renders it where it's supposed to go. But very quickly, the server says, no, 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 you're not allowed to do that. So my cache gets fixed to reflect the real server's database, which in this case means there's no circle. So on the local client, I get this funny effect where for a split second, I have this strange extra result. But the other client never sees that. So as I double click to make these circles, you'll notice they never appear in Safari. They're never in the server's database. They're not being sent to anyone else. It's just this temporary effect on the client. Most of the time, you're not going to let your client do this, right? You're going to impose rules on the client that you know the server is going to agree with. So a well-behaved client won't get you in this position. But it's a good demonstration of how we can speculatively do work on the client without waiting for the server, hoping most of the time that you get the right result. So let me go ahead and add an insert rule. And insert is going to take a user ID and the proposed document. And again, I'll just return true to allow any client to insert a document. And yep, now we're back. And what we now have is where we were at the beginning, except that each client is manually subscribing to its documents, and each client is using the rules for updating objects. And it looks like I have one more, right? I can't change the color of a circle because I didn't allow an update, and so I can add that update as well. Update, I'm not sure quite what it takes, but I think that will work. And now we're back to where we were. So in this application, if you want to think of the client and the server as speaking this protocol or having an API between them, the way we can think about security is actually very clear. And the rule is the server gets to decide what the client can see. That's a publish function. And the server gets to decide whether or not the client can make an update. That's the allow function. That's it, right? There's nothing else the client can ever do. I can write all the rogue code I want on the client. I can go to the console and type any JavaScript I want. Maybe I affect the client screen briefly like we saw before, but fundamentally, there's nothing that client can do now other than specifically what the server chose to allow it to do. And that's the foundation of security in a rich client application. And what we've done here is create a framework that lets us think about that in a really structured way. And I can show you examples of like what happens when you play with that. So for example, I can turn off that publish on the server, and if I go back to my web browser, all the data's gone. The server stopped providing that data. In fact, it removed it from its cache. And if I do a database query for all of the circles, there aren't any on either client because the server chose not to provide them anymore. Or maybe the server is only going to provide a total of 2 circles, kind of a weird thing to do, but let's just imagine. I can write any query here I want. So we come back over to our clients, and they both have 2 circles. Right? So we're under complete control of what data each person's allowed to see. So now that we have the primitive, I want to take that one step further, and I want to actually create some sort of login system so that maybe I can vary the behavior of the app based on whether or not I'm logged in or I'm someone that the server knows about. Yeah? What happens if I create a circle at this point? What do you think? So if I double click here, actually let me do an insert just to be really explicit about it. So I'll do circle.insert. And let's just say x0, y0, color 0, radius really big. Okay, so what's going to happen? Well, that insert is going to immediately change the cache on my client. So I'm pretty sure I'm going to get a big circle on my screen, right? And it's going to send a command to the server to add a circle to the database, which I'm allowing, right? Because the clients are allowed to insert records. So there should be 4 circles in the real database at that point. But the server isn't going, I'm not subscribed to all 4. I'm only subscribed to 2 of them. So what ought to end up happening is that I'll still only have 2 circles on the screen. Which 2? I'm not sure, because the query I wrote wasn't very well defined, right? I just said, give me 2 circles. I didn't sort them. So let's see. If I could type right. And there you go. So same thing, latency compensation. The client simulated what it thought was going to happen. Surprisingly, that's not actually what happened to its cache, and the server resolved it to where it is now. But of course, those circles are in the database, and if I get rid of this goofy limit and I just go back to publishing all the circles to the clients, there they all are, right? So the primitives are really solid. Now, I admit this is a little bizarre, because who cares about managing circles, but let's just play along for a second. So I want to show you how easy it is to add logins to an application like this and then vary the behavior in a slightly more useful way, let's say. And to do that, I'm going to use new packages that are part of this security release. So I'm going to add accounts UI and accounts password. So the first provides me some Chrome around a login system, and the second provides me an implementation of accounts that are backed by username and password. Sorry. And then in my HTML file, I'm going to add a login buttons helper, which is something that the Chrome, the accounts UI package, provides me. And I save the file. By the way, when I save files in Meteor, clients automatically update. So you're not seeing me refresh the browser. We call that a hot code push. It's really helpful for development, but it's super important for production. Because if you think about a production application that's written in JavaScript, reloading the whole browser is sort of like rebooting Windows 95 when you installed a piece of software, right? The user's probably in the middle of something. What if they have a dialog open and they're halfway through filling out a form? We're all fans of continuous deployment, so we make our change to tweak the color of something, and this whole new set of code gets pushed out, and the guy's work gets lost, right? So there's underlying technology to make these sorts of applications work really well that turns out to be important, and that's one example of it. So I saved that login button helper, and now I have this little sign-in thing, and I can, yeah. I was talking about continuous deployment, and
does that have hot code deploy if I change the files underneath it?
Yeah.
Okay, so I tried that, it didn't seem to work. I just wanted to understand.
The question is, can you do hot code deploy if you do Meteor bundle? I sure thought so. I'm only like 90% sure. We can talk offline. Let's talk after. Yeah, it's just kind of detailed. Okay, so Chrome gives me this sign-in box. I don't have an account, but I can create one, and I'll just say I'm Matt at Meteor, and my password is 1 through 6 or something like that. And now I'm logged in as Matt at Meteor. Well, here's what's interesting about being logged in, is I can run this command Meteor user in the console, and my client returns to me an object, which is, it turns out, a collection of users. And when I'm logged in, the server will publish me the record or the document for my user. So I didn't write any code, but I'm now logged in, and I have this record that I can work with, and buried in here is my email address that I typed in. The same information is available on the server. So let's take advantage of that. Let's say that you only get to see green circles if you're logged in. Anybody can see red circles, but green circles are special, and you got to be logged in to see them. So that's a very simple change. I'm going to go back to my publish function, and I'm going to check to see if the user's logged in. So if, and I have access to this.userid on the server. I could probably write this more elegantly, but I'll just do it the dopey way. So I'll return all the circles if there's a user ID. And if there's no user ID, then I'll only return circles whose color is 0, which I think is a red circle. Does that make sense? So I save that file, and I go over to Chrome, and there's nothing different, and that makes sense because I'm logged in, and so I should still see the whole database. But if I go over to Safari, that green circle's gone. And if I sign in, there's the circle. So the server is aware of the state, and I mentioned before, and it wasn't really obvious why I thought this was so important, but I talked about how this protocol has to be stateful, because in a rich application like this, it's not, you know, an occasional conversation back and forth. There is a continuous stream of data going back and forth, and the contents of that stream, the result of a query from the server, is a property of the client, and it's a property of, in particular, who I'm logged in as. So if I log in, I get all this data. If I sign out, the server is going to remove data from my cache, and then D3, you know, beautifully zooms that down to nothing. And there's sort of funny consequences here, right? Because if I click on a circle, I'm going to change its color. Well, that's going to remove it from the client. I think I had an overlapping circle there. You know, same story there, right? I can do a little bit more with the login system. So suppose I want to, instead of having this username password business, maybe I want to use a login provider like Google Oauth or Facebook Oauth. That's easy too. So I can do Meteor add accounts Google, for example. And I go back to my application, and let me sign out as a user. And I now have this Google login option in addition to my password, but it's not configured yet. So there's a little wizard that I'm going to get that lets me configure it. And if I click on that, I get this little dialog that sort of explains to me what the drill is. If you've used Oauth, this is going to look really familiar. With Oauth 2, you're going to get a client ID, which represents the application on the provider side, and you're going to get a secret that's only known to the provider and to your application. So you can go to code.google.com and create a new project. I like Google because it's very easy to do. Some of the other providers are hard to follow. I am going to, I stashed away my existing apps information. So let me just copy that in here. So again, just the identifier for the Oauth app that I have at Google and the secret for the app at Google, and I save my configuration. And now I'm all set. So now I can sign in with Google. So I click sign in, I get the pop-up. You've seen this before. I guess I'm already signed in as Meteor. Now I'm logged in, and I got my green circles back. It even knows my name, right? Because Oauth providers give you certain data as part of the Oauth process. I don't know any other framework that lets me log in quite this fast, right? And the cool thing is the same logic I can use to inspect the state of my login status on the server, the way that publish changed behavior based on who I was, applies to both the username password style that I used as well as the use of another provider, right? So I can vary my whole application based on this. Yeah, the question is about the wizard. You can also configure that in code. I think like WordPress or someone a long time ago sort of started this trend, right? The first time you deploy an app, it gives you that magic configuration box. I think in most cases that works really well, but you can turn that off if you're worried about. Yeah, I mean, presumably you're on the ball, right? It's your app and you're the one deploying it, but no, it's a fair question. So you don't have to use that wizard. But one of our philosophies is let's make it really easy for people to get started. Let's not let things like Oauth is a pain, or I don't want to have to worry about security when I first build my app. I just want to play with an interface because it's going to take me a while to even understand what my data model looks like. It's why we like Mongo, because you don't have to define a schema and you can play with different ideas very flexibly. And I think the Meteor D3 Mongo combination, even as goofy as this is, I think shows you sort of how interesting it can be to work with live sets of data that are changing, where you have different permissions or different sets of users that can see different information. The question is, what are the dependencies for Meteor? So we implemented support for Mongo first, just because of its popularity. There's nothing in Meteor that requires Mongo in terms of the architecture. We just haven't written the connectors for other things. So I could have done this whole demo typing SQL queries in the browser and talking to a SQL database here on the screen. We just haven't built that binding, the SQL implementation, that will let you do that. So SQL, Redis, Dynamo, all of these things I think make sense. It's just that Mongo is such a good fit, and when we first built Meteor, we wanted to pick the one that was most helpful. In terms of other dependencies, we try to keep it pretty self-contained. I mean, we use a lot of technology, but Meteor is a one install thing. You don't have to go find a bunch of stuff. So Node.js, of course, which is the server JavaScript environment. Handlebars I mentioned for templating. The Mongo database comes with Meteor. I mean, this demo itself has D3 and jQuery and a couple other libraries, and those are all included as packages. So there's a large set of things that we use, but we try to make the development experience very simple and contained. Okay, so the question is, what do we do in a hot code deploy if basically you pull the rug out from under the user? It's a good question. So I'll show you the way that's implemented, just real quick. So on the client, you have a session object. And session is just a basic dictionary that you can get and set data from. So I can do session set, example to be 10. And then I can do session.get example, and I get back 10, right? Very, very simple. It's not persisted on the server. It's not copied to any other client. If I went to Safari and did session get example, it would be undefined because it's separate. If I go to my app and I just make a change and save and I do a hot code push, and you saw the browser flicker, right? The only way to do a hot code push is actually to reload the browser right now. There's something that will change eventually. My session is still 10. So session is a module in Meteor that cooperates with hot code push to serialize all of its data before being reset by the browser refresh, and then reestablishes those values. That's the core piece that you would use to implement a modal. So you'd have a dialog and you'd have a session variable that basically said whether or not the dialog was on the screen, right? So typically in a hot code push, if the dialog's up on the screen, browser refreshes, session variable gets reestablished, the templates that look for that session variable are redrawn and everything is as it was. If you just outright remove the template, then it's whatever your app would put the user in with that state. So that's just an application decision. But again, I would stress how important that is because think about a modal and think about someone's in the middle of doing something and all of a sudden they're not, right? That's not okay in a world where we're trying to deploy every hour. The question is about statefulness on the server. So the real state is in the Mongo database in what I've been showing you. In fact, I cannot resist doing this demo because it's so much fun. So, okay, my app is still running. I'll go back to localhost. I forget what bizarre state I've left the world in. Okay, I can create some circles, and they appear on Safari at the same time. Okay, I'm going to kill the server. I'm just going to kill the node process completely. First interesting thing is I can still create circles. Why? Because Number one, my app is running on my browser, so it's unaffected. The HA story for a client-side application is really interesting, right? Because you have brains on the client, and it can make some smart decisions. So I can still take some actions. And I'm simulating, remember, what's really happening is I'm doing an RPC to the server to insert a new record. Well, I'm simulating that on the client. So the client merrily goes along, assuming the insert is going to succeed, which it will, and goes ahead and puts that circle on the screen. Of course, that is not reflected on the other browsers because there's absolutely no connection. And I can even, I can do Meteor. I think it's status. Status. This is sort of an embarrassing. OK, so the status of the connection is waiting. I'm no longer connected to the server. And then I can rerun the server. And again, there's no state left over. And what's going to happen here is that the browsers are going to, they're checking every so often. It's like an exponential back off like you'd expect. But if all goes well, what you're going to see is let me just force it. And there now, all the data has been saved to the server and transmitted over. So the question is, what happened on that reconnect? And again, that gets back to what I was talking about, having a stateful protocol. So a couple of really important things happened in this demonstration with that protocol. One is that the clients retry RPCs, and they're reliable, right? So until they hear a result from the server, they're going to hold on to that queued RPC. And we had 3 or 4 of them queued up with each insert until they were finally reconnected to the server and ran. Right, and the other half of the question is, you want a stateful protocol, and that protocol has to survive transport failure. So in this case, I'm not signed in, so there's not a whole lot of client state, actually. But we could have done that demo. I mean, I was logged in on the left, and that survived the reconnect. So thank you. Thank you very much.